This week on the Agent Factory.
So LM evaluation is like a school exam. You're testing knowledge with static Q&A. But agent evaluation is more like a job performance review.
That's it. This is how you can cover the full loop with ADK Web. As we saw, it's very fast.
So this end-to-end evaluation is one of the most important things in multi-agent system.
Hi everyone, welcome to the Agent Factory. This is a podcast where we talk about agents and how to put them into production. I'm Ivan.
Hi, I'm Annie. It's so great to be here. And today's topic is one of the most complex but also most important one, that is agent evaluation.
That's right. We had a lot of questions about this one, so today we are trying to answer some of them.
Exactly. So we will cover everything about what agent evaluation really means and what you should be measuring, how to do it using ADK and Vertex AI, and we'll even explain advanced topics like evaluation in multi-agent system. So if you ever wonder, how do I know if my agent is actually working well? This is the episode for you.
Exactly. And as always, if you find this useful, make sure to subscribe to the Google Cloud Tech channel and activate notification so you can hear about the new episode as soon as it gets released. But now, let's get started.
Sure.
So, Annie, let's start with a very simple question. Like, what is agent evaluation?
All right, that's a really good question. You can think of an agent as a really complex system. When you're evaluating it, it isn't just about checking whether the final answer looks right. With traditional software, tests are pretty straightforward, right? You check if A equals to B. But with LM agent, it is very different. You have to look at the whole system.
Exactly. So we need to look at things like, can the agent actually complete the task?
Yeah.
Does it make good decision along the way? Or how well does it use tools, memory, and even the reasoning?
Yeah, so it not just say, hey, did it give the right answer or not? It's about system-level behavior, things like autonomy, multi-step reasoning, tool usage, and how well the agent handles unpredictable situations.
Okay, so how is this different from traditional testing or even from, standard LLM evaluation?
That is a really great question. The traditional testing is deterministic. It's the same input, same output for almost every single time, right? It's very perfect for unit tests like fail to check pass or failure. But agents don't work that way. Agents are variable. You can give the same prompt twice, but it might end up with two complete different outcomes, right?
So you can just write a PyTest that says, agents that asserts agent response equal to expected. And this is because you will end up with a very flaky test suite. Instead, instead of focusing on single outputs, we have to look at the behavior over time. This explains the difference between, traditional software testing and agent evaluation. But how is that different from LLM benchmarks like MMLAU?
Yeah, so LM evaluation and agent evaluation are very different. So LM evaluation is like a school exam. You're testing knowledge with static Q&A. But agent evaluation is more like a job performance review. We care about whether agent can use tools correctly or recover from errors or stay consistent across multiple turns. So even if you have a really great model, your agent can still perform badly because the agent might not call API properly, right?
I see. So the big take here is that traditional testing is for deterministic logic, LLM evaluation is for general model capabilities, but agent evaluation is for system-level task effectiveness.
So when we talk about evaluating an agent, the short answer is you need to measure everything. You really need a full-stack approach. And let's walk through what that really means.
Yeah, let's begin with the final outcome. So here you need metrics that tells you if the agent actually achieved its goal. That's where we want to look at task success rate, for example. But that's not the whole story. Like we also care about the quality of the output. For example, was it coherent, accurate, and safe? Did it avoid hallucination and biased responses? So it's not just did it finish the job? It's did it finish it well?
Exactly. And what's next is agent's chain of thought. It's planning and reasoning. So we'll ask, did it break the task into logical steps? Was the reasoning actually consistent? Or did it just get lucky and land the right answer by chance? Because if the reasoning isn't solid, it won't hold up across different rounds.
That's right. And we also want to look at the tool utilization, right? So if the agent picked the right tool or did it pass the correct parameters. So, and it's not just about the right tool and parameters. Did it do it efficiently? So, or for example, it wastes time and money making redundant API calls.
Yeah.
I've seen many agents stuck in this loop, going through the same API calls and driving up costs.
Yeah, that's right. So that's why we need to track it. And finally, we have this memory and context retention. Can the agent recall the right information when it actually needs it? Or when new information conflict with what it already knows? Can agent resolve that conflict correctly?
So again, as we said at the beginning, we really need to evaluate everything and try to find the right measures for all these aspects of the agents: outcome, reasoning, tools, and memory.
Right.
But so now we know what to cover. But the problem is how to measure the agent. So how do actually we evaluate an agent in practice?
Yeah, that's a great question. So to evaluate agent, we need to understand two big concepts. And the first concept is offline evaluation. The second concept is online evaluation. So offline is what you do before production. You test against static golden dataset to catch regression. And online is what happens after deployment. So you're monitoring live user data, looking for drift, or even running A/B tests.
Got it. So this is the classic distinction between pre-production versus post-production evaluation. And within both, we have some popular methods that users or developers use in order to evaluate the agents. The first one is the ground truth checks. So they are fast, cheap, and reliable. You try to answer questions like, is this a valid JSON that has been generated, or does the format match with the schema? So the limitation of this check is that the fact that they don't capture nuances of the agent outputs. Or there are some aspects like, coherence, factuality of the agents that are very hard to measure.
That makes so much sense. And that's why we have this LLM as a judge. So this is when you use a strong model to score subjective qualities, like how coherent the plan is. The great thing about this is it scales really well. But how they evaluate really depends on how they were trained.
Yeah, exactly. And, in order to compensate these two methods, we have a third and last method that is pretty popular. And as you can imagine, is the human in the loop.
Right.
So that's when domain experts review the output of the agents. This is one of the most specialized methods in some sense, but it's also slower and the most expensive.
I can imagine that. But do you just pick one of those, or do all of them work better together?
No, all of them, as we just saw, they have pros and cons.
Yeah.
So the best strategy here is combining them. In particular, what you want to create is what is called a calibration loop.
Okay.
So you start with the human to create a small, high-quality golden dataset, and then you fine-tune your LLM as a judge till its core, they line up with the human expectations.
Oh, so you get the best of both. You get the best of both accuracy of human and the scale of LLM. That's a key. All right. So now I get the concept, but how do we actually put this into practice?
Yeah, so let's try to run an agent evaluation here.
Okay.
So actually, what we can do is that we can use Agent Development Kit. And in Agent Development Kit, you have ADK Web that will help us.
Yeah, right. ADK Web is so handy for this offline inner loop development. It built for fast interactive testing, exactly the kind of offline evaluation we just talked about. And let's walk through this 5-step loop altogether.
Yeah, perfect. So let's use a very simple agent, product research agent as an example.
Right, you can see this agent has two tools. The first tool called Get Product Details for customer-facing info. And the second tool is Look Up Product Information for internal SKUs. But the issue with this agent is the instruction wasn't clear enough.
Yeah, so that's why, let's go through the first step.
Okay.
So in order to, first of all, we want to test the agent and define, the golden path. So in the ADK Web UI, I can type, hey, tell me about the headphones, for example, and the agent comes back with an SKU. But that's an internal data, and we don't want it. So in the eval tab, what I can do is that I can create a case and correct the expected response to the customer description of the product that I expect. So this is how you create a golden data set with ADK Web.
Right. So once you have this data set, let's go to next step, which is evaluate the agent. As a developer, I select the test case and click Run Evaluation button. And then you can see from this demo that it fails right away. So that's why we go to the next step, which is about finding the root cause. And you can see I jump into this trace tab. And here is a magic happens. It shows the agent's step-by-step reasoning process. And from here, I realize, oh, okay, the agent chose the wrong tool, look at product information.
Yeah, once you have this kind of information, then you can fix the agent. So in this very simple case, the problem, as we said, it was the instruction was too ambiguous. So I can open my agent code and write the instruction to be more clear.
Yeah.
For example, I can write something like for customer-facing description, use the get product details, and for internal data like SKU, use the lookup product information.
Okay, so now we fix it. And then we need to go to the next step, which is validating the agent. So ADK server how reloads, I run the same test again. Okay, tell me the headphones. And this time it gave me the correct customer description. So by rerunning evaluation, the test passed.
Yeah, so and that's it. This is how you can cover the full loop with ADK Web. As we saw, it's very fast and it gives you this interactive debugging and testing.
Yeah, that is a solid workflow. But just to note, ADK doesn't stop there. It also supports running unit tests and integration tests. But here's a catch. It's still manual and interactive, right? It only covers a limited set of metrics. That's okay for development, but it doesn't scale. So this brings us to the next step, evaluating with Vertex AI.
Exactly. So anyway, when you need to test at scale or evaluating at scale and you want richer metrics, like using LLM as a judge, as we were saying, you need a production-grade platform. And that's where Vertex AI comes in. So with Vertex AI, you can take your eval stats and run them through the GenAI evaluation services. So it is designed to handle this complex qualitative evaluation for your agents at scale. And it produces an evaluation outcomes that you can also use to build dashboard for your agent in production.
Yeah, so basically ADK is for your fast inner loop during development, and Vertex AI is a production scale outer loop.
Yeah, you got it. So, and of course, as you can imagine, Vertex AI is just one option. There are so many platforms out there that you can use to evaluate your agents.
Yeah, so we work through how to evaluate agents with ADK and Vertex AI. But here's the problem. In both cases, you need dataset. But honestly, that's not always available. Or even dataset is available, it can be very expensive or very hard to create. That is what we call cold start problem.
Exactly. And the way we handle this is with something called a synthetic data generation. So basically, we use an LLM to create the dataset for us. We build a data generation pipeline together with Bayes and biases some time ago. And we can explain a generic process here.
Yeah, sure. So you can think of this as 4-step recipe. And the first step is you ask LLM to generate realistic user tasks. And next step is you have it act like an expert agent and produce the perfect step-by-step solution. And third is if you want, you can bring a weaker model to try the same task, which gives you a bunch of imperfect attempts. So now you have both attempts, and finally, you use an LLM as a judge to compare those imperfect attempts against the perfect solution and score them automatically.
Yeah, that's nice. So we got a way to build our evaluation data, but I know developer what may ask, now we have this data, but how actually use it to design tests at scale?
Yeah, that is a really great question. So that's where this 3-tier testing strategy comes in.
Yeah, tell more about this.
Sure. So the first tier is unit test. Just like the example we had before, the production research agent, you're testing one small piece in isolation. And the tier 2 is integration test. It's like taking the whole car for a test drive. You're not just checking the single component, you're checking if the whole multi-step journey works the way it should. And tier 3 is end-to-end human review and multi-agent testing. This is a final sanity check. It's also where you bring in multiple agents and feed results back into your human in-the-loop calibration loop.
That's a really interesting framework.
Yeah.
And I really would like to see it in practice. Maybe we can have a future episode on this.
Sure.
But for now, we pretty much covered the A to Z of evaluating a single agent, which leaves one big question. What happens when you got multiple agents working together?
Yeah, so here's the thing. When we move into multi-agent system for really complex tasks, our whole approach for evaluation has to evolve.
Yeah, the issue is that judging agents in isolations doesn't tell much about the system overall performance. That's especially true if you start using, this new framework to build multi-agent systems like the agent-to-agent protocol, which is all about agent discovery and talk to each other more easily.
Yeah, right, exactly. So in a multi-agent setup, you don't just care about reasoning or tool use. You care about whether the whole system gets the job done.
Sure. So to explain why this is relevant, let's have a quick example. So let's imagine that we have an agent A, which is for customer support, and an agent B that is for refund and replacement process.
Yeah.
So a customer comes to agent A and say, I bought a smart widget last week and it doesn't turn on. So I really would like to have a refund or a replacement.
Right. So in that case, what happens next is agent A kicks things off. It generates a greeting tool and check customer info and look up purchase history and confirm the order. But here's the key. It can't actually process a refund. And instead, its job is to hand everything over to agent B, including all the customer details and product information.
Yeah, and then the agent B takes it from there, and the agent B reviews the case, uses a specialized tool for refunding or replacement to finish the request. But here is the problem. If you look at the agent A in isolation, depending on the metrics that you use, for example, a task score completion score would be 0, and it didn't solve the problem. But in the reality, it succeeded 100% because its role was to hand off to the agent B.
Yeah, that's right. And if agent B successfully processed the refund, that is great. But what if agent A has passed the wrong information and the system as a whole will still fail, right? So that's why single agent matrix can be totally misleading.
Yeah, so what really matters here is that can the agent hand off smoothly, share contacts, and keep latency and cost reasonable across the whole journey?
Exactly. So this end-to-end evaluation is one of the most important things in multi-agent system, which means evaluation itself become part of the design. And we may even need agents that can emit structured data specifically for evaluation purpose.
Yeah, I like the idea. And I kind of seeing, multi-agent evaluation like a network analysis where, you look at interaction and not just the outcomes. I really would like to spend some time looking more into that.
Sure, totally. So it's not just about hands-off. It's also about collaboration, communication efficiency, conflict resolution, and this is just one of the open questions in this whole agent evaluation world.
Yeah, beside that, actually, there are many others. For example, there is this scalability cost trade-off. So as we were saying, human evaluation are still a valid option, but at the same time is low and expensive. So you can use LLM as a judge, which is faster and scalable, but in order to align them to the human expectation, you need to tune them. So there we go, the trade-off with cost and performance.
Also, I heard about benchmark integrity. That also being a problem. If test questions leak into model training data, the score doesn't mean so much in this case. And once models start acing benchmark, we will have to build even harder ones.
Yeah, exactly. And another one, which is the last one I just want to mention, is these subjective attributes evaluation. So things like creativity, proactivity, even humor. How do you measure those with your agent? Like imagine an agent and produce image. How an agent is good in producing them. These are still this kind of question they still not have a clear answer yet.
Yeah, those are really tough challenge, but I think they're also very exciting challenge. And I really can't wait to see new evaluation framework to address those challenge. But for now, I think that is a perfect place to wrap things up.
Yeah, I think so. We really cover a lot today on agent evaluation.
Yeah.
We kicked things off with the basics, like what agent evaluation actually is, how it's different from traditional testing, as well as LLM evaluation. And we broke down this full stack approach, looking at the outcome, reasoning tools, and memory.
Yeah, and after that, we also walked through the concept of ground truth, LM as a judge, and human in the loop, and all the way down to what's next with multi-agent hands-off and the challenge of benchmarking.
Yeah, that's a lot of content about evaluations.
Yeah.
I hope now you have a better idea of how to evaluate your agent.
Yep.
And also, we will share some of the links of the resources that we just discussed in the show notes.
Yeah, that's right. Thank you so much for hanging out with us on this Agent Factory. And once more, if you enjoyed today's content and want to support us, making sure to subscribe to Google Cloud Tech channel, activate notification, like, comment, and share with everyone.
Yeah, and until next time, I'm Ivan.
I'm Annie.
Powering down.